Welcome to March's Leetcode challenge. Today's problem is coin change. You are given coins of different denominations and a total amount. Write a function to compute the fewest number of coins that you need to make up that amount. If that amount cannot be made up, return -1. You may assume you have an infinite number of each kind of coin. So if we had coins 1, 2, 5, we would return 3 because 2 5 coins and 1 coin would be the least amount of coins to get 11. Now, on the surface, this looks like a very simple problem. In the beginning, we might think like we could just sort our coin denominations and then do a while loop, subtracting the largest denomination first, and then trying to see if we can get the amount here. So here we'd get 1 5 coin, 2 5 coins, so now we have 1 left, and we move here, and then we have 1 coin. So that'd be 3 coins, right? But that wouldn't work because of certain situations like this, where we have, let's say, 1 4 5. If we had 8 coins, if that algorithm would be the same, we would take 5 here, and then we take 3 1 coins, which would equal 4. But we know that we can do 4 2s, and that would be 2 coins. That should be the minimum. So we need to keep track of the number of coins that we can make at each point. So really, that solution won't work. We'd have to go with something either recursive or DP. And I'm going to go with like a DP solution. What we'll do is create this into sub-problems and have some sort of DP array that contains the numbers all the way up to 8. What we'll do is just have some infinite max number here. I'm just going to call that, let's say -1, but assume that this is infinite. And what we'll do is, see, we keep track of the index points. So this is 0 amount 1, 2, 3, 4, 5, 6, 7, 8, something like that. And basically, we'll check for each coin denomination. Oh, we need one more here. How many coins would it take to fulfill that amount? So here, we'll start with 1 coin, or I'm sorry, we'll start with the amount 0. We know that there's no amount of coins that we can make to make, 0 amount. So this would just be 0 immediately. Now we have the amount 1, right? So out of these 3 coins, we run a for loop. If we use 1, then we could create it with 1 coin, right? What about 4? We can't do it with 5 either. So this would all be the same up to like 2, 3, 4, something like this. But once we reach 4, we know that we could have 4 1s, but we should also check 1 4. And we know that that's going to be the minimums. So that can be changed to like 1 4 coin. 5 wouldn't be work. Now what about at 5? Here we'll check. First see 5 1s. That'll work. Okay, so 5 1s, we'll update that. Now what about 4? Well, we obviously can't make 5 with 4, but we could make... we know that we could add 1 4 here and then go back 4 spaces to 1, see how many coins that it took to make 1, that's going to be the minimum here, and add that. So we know at 5 we can have 1 4 coin and use 1 1 coin here, and that would equal 2, right? So that gets updated to 2. And that's the algorithm, how that algorithm works. We like look backwards to see the minimum amount that we can make minus that coin amount and see if that's minimum. And if it is, we're going to update it. So hopefully that sort of made sense. What we'll do is create a DP array here. I'm going to start with making these all infinite values because we want to get the max value. And we'll say for I, or whatever, for blank in range of length of amount. We'll also need to add 1 here. Okay, so we have this DP array. We need to make the very first value 0. So we'll do that here. Now for, let's see. For I in range of length of DP, we are going to run through all our coins. So for C in coins, if this I minus C is greater or equal to 0, that means we're in bounds. So we could subtract the coin amount from our value here. We're going to update our I to be the minimum between DPI or DP I minus C and then add 1, which is the coin value right now that we're at. So if this is less, then we're going to update it. Otherwise, we'll keep the old one. So at the very end, we should have our DP amount for this number that we're trying to get, the amount, which would be the very last index in our DP array. Now, one thing to note, we want to return -1 if it's an infinite, right? Because that means that we weren't able to form that amount. If I made this -1 here, it wouldn't work with this algorithm. So what I'll have to do is say, if dp I-1 is equal to float infinite, then we'll return -1. Else, we'll just return the amount right there. All right, so let's see if this works. Object has no length. What do I do here? Oh, okay, I don't need length here. I just get the range of amounts. +1, I think. All right, so that looks like it's working. Let's go ahead and submit that. And accept it. So time complexity wise, it's going to be O of n, which is the number amount here times the number of coins. So let's say that's C times n. Now, I did see that there were some recursive solutions that did the exact same thing, but were way faster when we run it in Leetcode. I'm not entirely sure why that is, because time complexity wise, it should be the same. It could be that forming this array here takes a while, especially if the amount is large. I'm not entirely sure, so feel free to put that in the comments if you know why. But otherwise, this is the sort of accepted solution for this problem. It's a very classic one. All right, thanks for watching my channel, and remember, do not trust me, I know nothing.